Alright, so in this video we are going to be talking about telescoping series, so let's get started. So we have a problem over here, and in this demo problem I'm going to walk through, it's going to be all about telescoping series. So to give you a little bit of a background, I want you to figure out a way to solve this problem, and then I'm going to talk about something. So essentially, there is a type of series, we've seen arithmetic series, you have geometric series. I haven't talked about geometric series yet, but it's going to be another video. So I want you to, first off, we're going to take a look at this problem, and we're going to figure out what a telescoping series even is by solving this problem. And at the end of the video, you're going to feel pretty confident about telescoping series. So I want you to evaluate the problem and compute it. And in this problem, it's not really obvious what the answer is. We have 1 over square root of 100 plus square root of 99. So we have 1 over square root of 99 plus square root of 98. Square root of 91 over square root of 98 plus square root of 97. And this goes all the way until we hit 1 over square root of 2 plus square root of 1. So the first thing I'm going to do, and whenever a problem-solving technique is, whenever you see that you have radicals in the denominator, rationalize your denominators. So that's what we're going to do. We're going to rationalize the denominator over here. Let's rationalize our first denominator. Now we can multiply this by using a difference of squares factorization. So we can multiply by the conjugate. Minus root 99. And in our denominator, we're going to have the same thing. Now, this gives us, we're going to have in the numerator, a root 100, square root of 100, minus root 99, and this is going to be over, the, well, we know that the square roots will get cancelled, so all we have is 100 minus 99, which equals 1. So that means we have square root of 100 minus the square root of 99. So we've rationalized the first denominator. Now we could just rationalize every single denominator until we hit 1 plus root 2 plus root 1, but that would take a long time, and that's going to be really hard to evaluate. So we know over here we're going to have a square root of 100 minus the square root of 99. Now check out a pattern here. When we're going to rationalize this denominator, let's move on. Let's try to rationalize this. We're going to multiply by the conjugate. And check this out. When we multiply by the conjugate, it's going to cancel the square roots out, cancel the radicals. In the numerator, we're going to have square root of 99 minus square root of 98. And in the denominator, it's going to be 99 minus 98, which is 1. So again, we're going to add on square root of 99 minus the square root of 98, because that's what's going to be. And that's what's really happening here. Now, over here, if we rationalize this, it's the same thing. We're going to have the square root of 98 plus square root of 9 minus the square root of 97, because when we rationalize it, we're going to have 1 in the denominator. 97. And this is going to go all the way until we hit a term over here. Until we hit this. Now, when we're rationalizing this term, it's the same exact thing. We multiply by the conjugate. We have root 2 minus root 1. We're going to multiply by the denominator. And then the square roots cancel out. So we have root 2 minus root 1 over 1, since 2 minus 1 is 1. So this is the same exact thing. This is going to be root 2 minus root 1. I want you to see if you can find a pattern over here. Alright. So hopefully you see our pattern. Negative root 99 plus root 99, these cancel. These, negative square root of 98 plus the square root of 98 is going to cancel. And then since this pattern will continue until we hit this, that means that square root of 9, this will cancel out with the next term. And then this also tells us that the term before this is going to be 1. We're going to have a root 2 over here. And it's going to be plus root 3. That's going to be our other term. And now when we rationalize this, we're just going to get root 3 minus root 2. So this over here, that's root 3 minus root 2. The 2's get cancelled. And the 3 obviously got cancelled by the negative square root of 3 before it. And we can see that every single term here will just get cancelled. Now let's focus on the terms that aren't cancelled. The terms that aren't cancelled are root 100. We have square root of 100 here. And it's minus square root of 1. Now everything got cancelled, but there's nothing to cancel out since the pattern ends once we hit this term right here, the minus square root of 1. So it's going to stop once we hit the term right here. But every other term got cancelled in the sequence, or the series, telescoping series. So everything else got cancelled. Since everything got cancelled except the first and the last term, all we need to do is evaluate the first and the last term. So that's what we're going to do. The square root of 100 is 10. And the square root of 1 is just 1. So we have 10 minus 1, which is 9. And this entire telescoping series, when evaluated, is equal to 9. And now you can see what a telescoping series is. Every single term except the first and the last term gets cancelled out. So every single term. Now the hard part about this is to recognize when a telescoping series, when you see a telescoping series. In this example, if you already know the concept of a telescoping series, it's pretty easy to identify that you have a giveaway is that you have denominators. So when you rationalize them, you're going to have a negative over here, and these are the same except for their signs. When you rationalize them, the signs change, so that means they're going to cancel out. Same thing over here. The signs are going to be different. That's going to be a negative right there when you rationalize it. And of course, you're going to have over here, there's going to be another term. If the pattern continues, you have a root 2 over here, root 2. But of course, this is going to be a negative once you rationalize it. And the only terms that don't get canceled is the root 1 and the root 100. So these two don't get canceled. So hopefully this video was helpful, and yeah, it's telescoping series.